So here we are in Module 1. Jeff, we're raring to go. We're ready to cover some Transact SQL, and we'll cover some basic selecting in this module. We'll cover the basics of using the select keyword and getting started with Transact SQL. So here's what we're going to cover in the module. There's an introduction to Transact SQL itself. We'll talk a little bit about relational databases. This isn't a database design course. Jeff, I know you're dying to dive in there and talk about normalization and all that stuff. We'll really just give you enough information to understand the context within which we'll use Transact SQL. If you do want to learn more about creating databases and designing databases, there's lots of other courses that you can take a look at that will cover that. So we'll look at that. We'll look at some details of how we relate to objects in the database, and then we'll dive into actually using Transact SQL itself and then get ourselves started. So by the end of this module, we'll have written our first Transact SQL queries. So let's start with a little bit about what actually Transact SQL is. And the SQL part of it, or the SQL, stands for Structured Query Language. And it was developed by IBM in the 1970s as a way of interrogating databases, which is where we're storing information that applications use typically. So it has been since adopted as a standard. The American National Standards Institute and the International Standards Organization have adopted it. And as a result of that, you'll find that it's widely used across lots of different database platforms. It isn't a Microsoft-specific thing. It's a language that's used by database platforms from all different vendors and all over the world. So, having said that, each vendor tends to add its own little idiosyncrasies to the language or little extensions to the language, and Microsoft's no different. Microsoft's implementation is referred to as Transact SQL, or sometimes T-SQL. And it's largely similar to SQL on any other platform that you might have used. So if you've used Oracle with PL SQL as the language there, or you've used other SQL-based databases, you'll find a lot of the syntax very similar and pretty much standard, but there are a few Microsoft-specific twists on it in Transact SQL. And it's the query language that's used for Microsoft's database products. And those database products include SQL Server, which is the enterprise-scale database server that you can install on your own hardware, or now you can run it in a virtual machine in Azure. And there's also Azure SQL Database, which is our platform as a service. So that's another place we can use it.
Do you get all the T-SQL in the Azure SQL Database? Is it exactly the same as SQL Server?
That's a good point. Azure SQL Database supports a pretty large subset of the full syntax that's supported in SQL Server. There are a number of things that are specific to SQL Server because they relate to local files or to the other area is the common language runtime data types that are things we can do in SQL Server that involve writing code in .NET rather than Transact SQL and then wrapping them up, which we don't necessarily want to do in Azure SQL Database. So there are some things that are SQL Server only. There's an increasing body of things that are supported in Azure SQL Database. And what you'll find is Azure SQL Database is constantly being updated with new features and new support for Transact SQL constructs that were previously only available in SQL Server. So as you use it, check with the latest version, have a look at the documentation and see what's available to use. The other point that's worth making about the SQL language generally is it's a declarative language, not a procedural language. What do I mean by that? Well, if you're a programmer, you've probably written some iterative programming. So maybe, Jeff, in C# or something, you might write a procedure where you do one thing, then do the next thing, and maybe you loop around and do a number of things a certain number of times, but you're specifying the steps, you're specifying the procedure. SQL is slightly different from that. In SQL, we generally work with what we call sets of data. If you're familiar with set theory, which is a branch of mathematics, you're used to the idea of collections of objects, and you typically draw Venn diagrams to categorize different sets together. SQL is a language that builds on that branch of mathematics. It's very much about dealing with multiple instances of objects that are arranged into collections or sets. And what you typically do, the best piece of advice I can give you when you're working with SQL is describe what it is you want. When you're writing a query that brings data from the tables, you're going to use the language to express what the result that you want to get. Don't express how you want to get that result or what the steps are.
So you're not doing a row at a time?
No,
going through?
typically you're not. There's the odd occasion when you might do something iterative, and later in the course we'll talk about how we can write programs effectively using SQL in a procedural style. But if you're doing that a lot, if you're building a database solution and you're writing a lot of procedural code in SQL, chances are there's a better way you could be doing things. It will perform better, it will work better if you use this declarative set-based approach. Mm-hmm. And that's what we're going to be focusing on through the course. So, relational databases, Jeff. Tell me what you know about relational databases.
Typically, you've got multiple tables, mm-hmm. and being relational, they relate to each other. So each table represents a type of thing. So what we call an entity would be let's say a person. It could be something you can't see as well. So it could be an order.
Okay.
And each table is designed to contain one type of thing.
Okay. And we tend to talk about these entities in the kind of classical academic world. They're referred to as relations. Day to day, we call them tables. So if you see somebody talking about relations, we're talking about tables. And it's similarly, sometimes people will say that relations have domains, or really those are columns. That's the term we generally mean. And what we're saying is those are the attributes of that entity. So a product entity would represent as a table, and that table may have columns that represent different attributes of a product. So its name, its price, its color, that type of thing. The other thing, and we're not going to dive into this too deeply, but you mentioned they have relationships, and that's interesting as well. Most databases are what we call normalized. Now, not all of them are. There are some special types of databases where we deliberately denormalize, but we're not going to get into any of that in any detail. What we are going to talk about is the idea that we have these multiple tables. What we try and do in each table is have a unique identifier called its primary key that uniquely identifies a row in that table, an instance of the entity. So we can uniquely identify a product, perhaps by some sort of unique product ID. And similarly, we might uniquely identify a sales order by a sales order number or something like that. We then relate those entities to each other. We relate, in this case, a product to a sales order. Which order did you buy? Using a relationship between the primary key that uniquely identifies a product and a key value in the order table, which we would call a foreign key. And that foreign key is just effectively a lookup to the other table. So if you think about how you might track orders in something like Excel, where you've got a spreadsheet, it might just be one massive table, and you keep writing in the product name every time somebody buys that product. The point of a relational database is to not have that duplication. So we have one product table, one order table, and we'll look up the product key to get the details of the product. Does that make sense? I think that's probably enough in terms of understanding normalization for what our purpose is.
The only thing I'd say is that if people are coming entirely new to databases, that it's really important to look into database design as another topic, because like many people, like my first database project many years ago, I hadn't done that. And then down the line, you cause yourself a lot of work.
Yeah, absolutely. Understanding the principles on which it's based is really important. For the purposes of learning Transact SQL, the key thing to understand is the data might be spread across multiple tables, and you might have to somehow create relationships, figure out how to do those lookups between the tables. And we'll cover all of that as we look at the syntax. So getting more specific about the way that we work with things in SQL Server and Azure SQL Database, we have this notion of something called schemas, and we have objects. Now, the objects we'll deal with mostly are tables. There are other types of objects. There's views and stored procedures and various things that we'll meet as we travel through this. But most of the time we're talking about tables. And those tables are arranged into schemas. So the schemas are a namespace for the tables. They're a way of having some sort of extended name that helps us identify that table. And actually, the fully qualified name of an object in a database is the server name, followed by the database name, because a server could have multiple databases, followed by the schema name, because a database could have multiple schemas, followed by the individual object name. So that's how we uniquely identify someone.
So have you got to type all of that in every time you refer to a table?
You can do. And certainly with SQL Server you can. With Azure SQL Database, there's really no point, because in Azure you can only work in one database at a time. You can't traverse different databases. So you generally don't use that full syntax. What you actually do within the context of working in a database, you usually just take it down to the schema name and the object name. Now you can omit the schema name. It's an optional part of the syntax. You can just directly refer to an individual table, but that can cause some problems because tables can be ambiguously named. So if we have a look at an example here, I've got two schemas. I've got the sales schema and the production schema. And in the sales schema, I have a table called order. So its name is sales.order because that's the schema. And I have a table called customer, sales.customer. And then in the production table, I have a production.product, but I also have production.order. Now, that's going to be confusing because I've got two tables called order, and if I didn't specify the schema, then it's ambiguous which table I'm going to connect to. And SQL Server and Azure Database use various techniques to figure out which one should be the default one that it goes to. But generally, the general rule is be explicit, specify the schema and the object, and that way you'll be pretty clear about what object you want to access. So we've talked a little bit about the design of the database and the multiple tables and the way that they relate. We've talked a little bit about schemas and how we use the schema to uniquely identify the table we want to access. There are a number of different elements or statement types within the SQL language, and Jeff, I'm sure you're familiar with most of these across the board. We're focusing on what we call DML, data manipulation language, in this course. And that's the part of the language that's used for querying databases, so getting information out of tables or updating data that's in tables or deleting data, that type of thing. There are some of these other ones. There's DDL, data definition language, which you would use if you were creating a database or creating tables. You would use create and alter and drop to do these types of operations. And then there's another kind of branch of the language that you can think of as DCL, data control language, where you're setting permissions. You're securing the objects by assigning which users can access which objects. We don't cover those. We don't really cover DDL or DCL in this course. There are other courses. If you want to be a database developer, then you really want to learn the DDL type of stuff. There are database development courses available. And if you want to learn how to secure objects, if you want to be a database administrator, then we have administration courses and books, and there's all sorts of information on that. We're going to focus on DML.
And do you have to tell it which one you're going to be using?
No, the language is pretty rich, and the same query engine is used for all of these different types of statement. Even although technically create isn't a query, I'm not querying anything to get data, it's the query engine that runs it, and it understands what a select statement is versus what a create statement is. So you use the same interface and you can mix and match these different types of language. So let's start with a select statement. It's probably the cornerstone of working with Transact SQL. It's the core statement that you will use when you're querying tables to get data out of the database. And it has a number of clauses. Don't worry too much about the details at this point. We are going to cover each of these different clauses as we go through the course. But I wanted to kind of put an example there that kind of shows almost the full kind of syntax of the select statement. And you can see that it starts with a select. So select is what we use to specify what columns do we want back? What do we want to see in the results? And that could be all of the columns in a table, or it could be specific columns in a table, or it could be columns from multiple tables, or it could even be literal values or expressions. But it's what do I want to see in the result? The result of a select statement is always a virtual table. Next, it's from. So okay, I want to see this data. If it's coming from existing tables, which tables is it coming from? So there's a from clause that I use to specify the source of where that data comes from. And then I might want to filter. I might not want all of the rows from those tables, so I might filter. So I have a where clause where I can say only bring back the rows where this condition is true. So we have a predicate statement, as it's called, that filters the rows that come back. Now a lot of statements are just simply select from where. That's a fairly common pattern. You might also want to aggregate and group data. So I might want to bring back not just the individual sales orders, but perhaps the totals for each month. So I might have a group by clause where I'm grouping the results by order date or order month. And then I might want to filter those groups. So I might want to say having a count of orders of over 100. So only bring back the months where we sold more than 100 items. So there's an additional having clause. And then the final clause that you usually see in a statement is an order by clause. By default, SQL does not return the results in any particular order. It just, whatever is the easiest way for it to get the data, the fastest way, it will use that and return the data in whatever order it happens to be in. If you want an explicit order, you want the data to be sorted in a particular order, you specify the order by clause. And we'll look at that in a bit more detail later on, but that's how we do that. So there's an example on the screen. Jeff, talk us through, what does that example actually do?
So we're selecting order date and a count of order ID. So we're not just displaying individual order IDs, we're going to count how many there are. So for each order date, we're going to count the order IDs. And because of that, if I jump forward a bit, we've got a group by order date. So it's saying group up the order dates, and for each one of those, show us a count of the order ID.
So we'll see how many orders on that day, basically, yeah.
From the sales order table, so you can see the schema that we mentioned before. So we've got the sales.sales order, so it's sales schema, sales order table. But we've filtered it. Now, we've filtered it in two ways there. So we've got a where clause, so that's saying before we've grouped it up, we're going to say where the status is shipped. And then we've also got a having clause, and that's after you've aggregated it, that's working on that aggregated data. So where, having already counted up the order IDs, I'm only interested in someone who's got an order, so I want order ID greater than 1, so I know there's more than one order on that date, so it will clear out all the empty dates, all the Saturdays and Sundays, whatever. And then
all
also
the dates where there is only one, in fact. It's
greater than one, sorry, yeah, if there's only one, it wouldn't display that.
Yeah.
Finally, we want to have it in order date order, because it can be actually, sometimes you can not put order by in and it comes out correctly because that's the order of the rows in the table, but actually it might work now.
That's a happy coincidence.
You might deliver this to someone and then suddenly it stops working down the line. So always put in an order by, even if it appears to order by, and it's order by descending, so if you don't want asset for whatever reason, we want our dates backwards.
Yeah, we want the most recent one at the top,
Yep.
basically. Yeah, okay. So that seems pretty straightforward then. I mean, I specify, and presumably the database engine then just executes each of those clauses in turn. Is that right?
Well, not strictly in turn. No, that's the slightly confusing thing about SQL in terms of it being a language. In terms of it is actually very English based. You can read SQL. It kind of makes sense in a sort of odd way. You can
once you get into that way of thinking, yeah.
But it doesn't work from top to bottom like other languages. So we're actually going to start with the table. So the from is the first thing it's going to do. It's saying, what tables do I need to get? And it's going out to the tables as the very first thing. And then we're going to go through and filter those tables. So we're going to say, okay, which rows do we want from that table? So before we've even looked at what rows, or what rather columns, we're selecting, we've actually gone out and said, okay, what are the rows we're interested in going to get for that data? Then we're going to go through and aggregate, not aggregate as such, but group up those rows by, in that case, order date. So we're going to segment them down to those order date buckets, essentially.
Okay.
And we want to filter that, so we can say, okay, then we want to work out only the ones that have got more than one order on that day. And then we can now get to the select. So now finally we're actually looking at what we wanted it to display. It is relevant actually, actually as we've only got one left, then we sort it. But it is relevant to think about it that way, because if you think of creating your query in that way, logically, that's how it's doing it. So if you think about the tables first and go through, rather than thinking about the row, the select column list first, actually think about what tables am I interested. So once we start doing joins and things like that, it becomes more of a setup to be done on that table portion.
Right.
Before we then move on to select later on.
So the principle is the query engine will first of all figure out the rows that it needs and then group them into whatever rows it needs. So it's grabbing them from the various source tables, grouping them, filtering those rows based on the where clause, and then if they're grouped on the having clause. And only at that point does it then start to worry about which individual columns it's going to actually bring back. So as you say, later on when we look at some examples, that becomes quite significant, the fact that it does it in that order. So it's worth being aware of that right from the very beginning. So a couple of basic examples on the slide. Let's just look at some examples. Here's probably the first query everybody writes. This is the Transact SQL equivalent of the Hello World application. This is the first thing you do: select * from, and then the name of a table. So
could we do select Hello World?
We could actually do select. Yeah, we could do
even
literally
simpler.
select hello world. It has no table. It just literally brings back the string. But if you're querying a table, which let's face it is generally the point, we'd have select stars as being an interesting starting point. And what that will do is bring back every column from that table. So, Jeff, would you expect an application to use a lot of those types of queries?
Well, no, it is one you run a lot because sometimes you just want to see what's in the table and it's quick. Mm-hmm. But the problem you've got is that someone might change the design of the table. And that could change. So if I'm presenting this as a finished record set to a developer of a web application, say, then what they get out of my query might change.
Right.
So I would be much happier to present them, even if it listed every single column, actually explicitly listing every single column would mean I know what they're getting, what order they're getting them in.
So it's about being explicit, and that makes it easier to keep track of any. If someone does change the design of the table, I at least can look at the query and know, well, those were the columns that I wanted.
Yes.
I guess the other point here as well is that applications are usually built across networks. So the client application might not be on the same server as the database, and if we're hosting it in Azure, it probably won't be. And if I do select star, but actually I only need the product name and the price, then I might be passing an awful lot of data unnecessarily across those network connections. And for one query, that might not matter, but if I'm doing this a couple 100,000 times, then that's going to add up. There's a lot of data that's unnecessarily being transferred. So I guess for that reason, I'd also probably avoid select star. So the alternative then is to specify the specific columns you want. So I might say select the exact example I used a minute ago, the name and the list price from the production.product table, bring that back, and that way I've just got the name column and the list price column. There's a couple of other things I might do as well here. There's a few little sort of additional things you might do in the select clause. You'll see I've got select name as product. And what I'm doing is saying bring back the name column, that's what it's called in the table. But in the result set that I'm going to create from this select statement and the virtual table that gets generated, I want to call that column product. So you're changing the name, if you like, of that product. And that's, in that example, we're just simply changing it because it's maybe confusing to have a column called name because we might have customer column with a customer name or something like that. But the other reason that you might do this is because you don't have to just select the value that's in a column. If you look at the second thing we're selecting from there, we've got list price multiplied by 0.9 as sale price. So we're applying a 10% discount. We've got an expression in there that's doing a calculation. And by default, if I didn't have that as sale price, what we call an alias, what I'd get is a column that doesn't have a name because it just gives me the result of the calculation. So you might use these aliases, and we'll see some examples of these in the demo. But it's worth being aware that sometimes you can use this as clause. The as itself is optional. You can miss out the word as. There's a lot of things in Transact SQL where individual words are optional. For various reasons, I'm going to recommend that you keep using as, and we'll see why when we have a look at the demo. But just to be aware that you might have an alias that names the column in this virtual result set, the virtual table that gets produced. And again, it's just worth being cognizant all of the time that whenever you have a select statement, the result of that is a virtual table. It's not a table that's stored in the database, but it's a row set, it's a record set of data.
So that as that you've used there, that alias, that's on the select line. So that's being created right towards the end of our SQL statement.
Yeah, and that's an important point. If you remember, the very last thing that gets done is the order by. So order by knows about aliases because those are declared in the select statement. So I could order by sale price, for example, but I couldn't group by sale price because the group by operation is done before we've got to the point where we've selected the columns.
Even
at that point, I only have the rows. Yeah. So it becomes quite important to understand the order in which statements are done if you're using aliases, because sometimes those aliases will be visible to other clauses, sometimes they won't. And typically, column aliases, which are expressed in the select statement, are only then visible to the order by clause. Any other clauses don't know about the aliases because we haven't got to that bit yet.
And if you're like me, then 20 years down the line, you'll still be doing this and you'll still be making that mistake.
Yes, it's a really common mistake.
You just quickly realise what you've
quickly
done.
remember what you did, yeah. All right, let's have a look at some basic select queries and understand how this works. I'm in SQL Server Management Studio, and I've connected to my Azure SQL database. And what I'm going to do is I'm going to create a new query by clicking the new query button. And I get this window appearing here into which I can start typing my Transact SQL. Now, before I type any Transact SQL code, I just want to notice which database I'm in. We talk about a database context as being the database that you're currently working in or that you're currently connected to. And you can see that by default it's connected me to a database called master, which is a system database that's used internally by the system. I actually want to be working in the AdventureWorks database, or the AdventureWorks LT database. So I'll go ahead and select that. And I'll guarantee you when you're working on the labs, at some point you'll find yourself in the wrong database and you'll get an error that says an object couldn't be found or something like that. Just double check that you're working in the right database as a little tip. So now that I'm there, I'm going to go ahead and start executing some Transact SQL. So I'll use my select statement. And I'll just go with every programmer's friend, the first program everybody ever writes. Here's the Transact SQL version of Hello World, or Hello Graham in this case. So if I select that, back it comes, it's one column, and it's got the literal string that I typed in there. So it's not particularly very useful, but it does at least show me that my select statement is working. It's bringing back that literal value. What I probably want to do, though, is to get some data from some tables in the database. So I'm going to select star from salesLT.product. Now let's just take a look at that for a second. SalesLT is the schema. You might remember we talked about tables belonging to a schema, and product is the name of the table. And the select star means bring back all of the columns. So I'm not specific about which columns I want. I want to see all of the columns in this table. And I'll go ahead and I'll execute that code. And sure enough, it brings back a huge big result set with data for all of the columns that are in that table. So I've got 295 rows there, I can see down here in the corner. And I've got all of these columns across here, including columns that I probably don't really need. I won't really need that RoGUID column or the thumbnail photo file name or any of these kind of things as I'm working with it. So that brings us to our first kind of best practice when you're working with Transact SQL, and that is only bring back what you need. Try and avoid using select star and explicitly saying which of the columns you're interested in. So in this case, I'm interested in the product ID, the name, the list price, and the standard cost. Now I could leave all that on one line like that. It doesn't really make any difference if you put a new line. I could put a whole bunch of new lines in there or space it out any way I like. The indicator that the end of the statement has been reached is this semicolon at the end. Now technically that's optional in the current releases of SQL Server and Azure SQL Database, but it's good practice to put a semicolon at the end of the statement just to be clear about that defines the entire statement that I want to run. So if I go ahead and execute that, I get back those 4 columns that I specified. I get back my ID, my name, my list price, and my standard cost. So far, so good. Now, what I might also want to do is I might want to bring back the list price minus the standard cost. So it's not a column, it's an expression. It's a calculation that I want the system to perform for me. So if I go ahead and run that, it works. It brings back the list price minus the standard cost. I can see that there. But of course, there's no column name here because it doesn't know what to call that column. It's not defined in the table, so it doesn't have a name. So what I will want to do is actually give it some sort of meaningful name. And I do that by saying as and then the name that I want to assign to it. And sure enough, it now comes back as a column named margin, which is pretty useful. Now, there is an alternative syntax that I can use. You don't actually have to use as. If I omit the as, it will still work. If I go ahead and run that, it still comes back being called margin. So you don't need the as. And if you're particularly lazy, you might think, well, that's fine. That'll save me typing 2 characters. I won't bother having that. The problem is, it's very easy to type a query. Perhaps, in this case, I want the color to come back. But I've forgotten to type in a comma to separate that out. And if I do that, what I actually get in this case is the list price minus the standard cost in a column called color, which doesn't make any sense whatsoever. And it's because I forgot to put in that missing comma, because that's actually what I wanted. So my second tip is make sure you always use the as keyword when you're assigning an alias to a column, so that we know that we're getting the proper name. And you can assign aliases to any column. It doesn't have to be ones that have got expressions. I could, if I just wanted to call standard cost, I could do that as well. And you can see that it works. So these aliases are just ways of renaming columns or assigning names to columns that are defined by calculations or expressions that wouldn't otherwise have a name. Okay, so we're getting some data out of here. We're seeing some of the syntax and tricks that we can use with it. Let's explore a little bit more of this idea of using expressions. And we've seen we did list price minus standard cost. Well, let's try something else. Let's get rid of our costs and our prices and start to think about the color and also the size. So we can start off by looking at the product ID, the name, the color, and the size. And you can see that the colors are, as you would expect, different colors. The sizes are, some of them are numbers, some of them are letters or character data, and some of them are null. So some of the sizes are unknown or not relevant or just missing. So what happens if I tell it that I want color plus size? So let's go ahead and run that. And I get no column name, as you would expect, but I do actually get something happening here. I get black 58. So the color was black, the size is 58, and this has been evaluated to be black 58. So it's not trying to add things together, as you might expect with a plus sign. Because these are both character columns, these are both strings, what it's doing is concatenating them. So I could give that a name, call it as style, and that's perhaps some way of defining my style as being some combination of the color and size. But you'll notice that where the size is null, what I don't get, I might expect to get, red without any size here, but I actually get null. And that's because of the way that nulls behave. Null means unknown. Null means I don't know what the value is here. So red plus something that I don't know equals something that I don't know. It's an unknown answer. So what we get is a null. It doesn't treat a null as being a blank string or an empty column. It treats it as being an unknown value. So when you add or you subtract or you do any sort of calculation or any sort of expression that uses a null, it usually then evaluates to null if any one of the two things that you're working with is a null. So that's worth being aware of as well. And then one final thing that's worth being aware of as well, I've got the color and the size, and some of the sizes are in fact numbers. So you might think that it's possible to do something like this. It doesn't make much sense, but I might say, show me the list price plus the size. And let's see what's going to happen there. And what's actually going to happen there is I'm going to get an error. And the error is, well, I can't do that because you're trying to do an operation that has a numerical value in the list price and a text value in the size column. So it doesn't add it together where it is a number. It just says, no, these two things are incompatible. You can't do that. You can't add a number to a string. I don't know what it is you want to try and do here. So I'm going to give you an error that says I can't convert it to the appropriate data type. It's actually a money data type, the list price. So we've seen some examples of how to use Transact SQL and how to create some queries. And we've also set ourselves up to look at some of the potential pitfalls, potential little problems that we might run across, which we'll explore in some of the later demos. So, data types in Transact SQL. Lots of different data types supported. Big table here. So we've got all these exact numerics. Jeff, what's an exact numeric?
Well, those ones we've got there are a number. They will appear, actually, to all intents and purposes, to be much the same, but you actually get this floating point numbers, and in a computer it can have a level of accuracy.
Oh, so like pi, for example, there's
no one
an
knows
unknown number of
what pi is ultimately, but we can say, well, it's roughly 3.14. Mm-hmm. So to the extent of where we actually are bothered to look at the decimal places, they probably will be the same. But if we need an absolutely specific, we know absolutely what that number equals down to x many decimal places, then it's an exact numeric number. And actually, some of those are integers as well. So integers don't have decimal places.
Yeah.
They're obviously the same. Okay. But the floats and reals they're like pi. Once you're getting out there, then they're not
after so many decimal
Absolutely.
places, we don't.
Yeah.
It could be inaccurate to a certain extent.
Yeah.
And I guess there are cases where we're prepared to accept that.
Well, and we have to accept
And we
that
have
with
to accept
things like
that.
pi, yeah.
Yeah. I noticed there's tiny int, small int, and big int. Seems to be a lot of ints going on there. What's that about? Why do I need so many different types of int?
Essentially, it's how much storage space we're allocating to that that number. So, because everything actually on a computer is binary, ultimately, then how many bits we assign to that number is going to define what we can put in that number. So we could start out with a binary number, and that would just be a 0 or 1, and then we can go up and say, okay, well, if we had a whole byte of that, then we could do a 0 to 255, and that would be great. It's really small, really efficient, except if you suddenly find you've actually got a 257 that you need to put in there, it won't work.
Right.
So then we go up through the stages. So then as you move up, you start to use multiple bytes, and actually it starts to use them not just 0 to, well, you go up to 65,535, bizarrely I remember that number. But it doesn't use all of that as a positive, because then it says, oh, well, you might want some negative numbers as well. So you get plus or minus.
Of course, yeah.
Half the numbers, and then as you go up, then the numbers become bigger and bigger and bigger.
Okay, so it's a factor of how much space is going to be used.
But keep them
in
as small
memory,
as you
yeah.
can. But obviously, if you're pushing the limit, if you think, well, I'm probably going to have a maximum of 255, probably you'd use the next one up. You
Right.
think, well, there's a chance I might. Go
You'd
over that.
overestimate, yeah. So, and I guess the important point from, I mean, this is all important stuff if you're designing and building tables, choosing the right data types. From the point of view of querying them, it can be important to know what data type you've got. At the very least, it's important to know, is it numeric, or is it character, or is it date, or is it, what is it? Because that determines how you can combine these things in expressions. We saw previously how I could concatenate strings using plus, or I could add numbers using plus. But I can't add a number to a string, and I can't concatenate a number to a string using a plus, because SQL Server doesn't know how that behavior works.
Even though you had a 58 in a load of those.
Yeah, even though
size
some of my
columns,
sizes were 58, because in the table it's defined as being a string. It's actually one of these character types. I believe it's actually varchar, which is a variable length character. You don't set aside a specific amount of space. You set aside the maximum amount of space and fill it with whatever you need. But it couldn't add the number 28 as a character to another number, because even although it's 28, it's not actually a number. The other important ones to be aware of, you'll occasionally see character data with an N in front of it, and that generally means, well, it doesn't generally mean, it means that we've set aside 2 bytes for each character. And the reason we might do that is if you've got characters that perhaps aren't in standard written English, perhaps they're kanji or Arabic characters that are stored. They're not stored in the standard sort of ASCII table of text, so we set aside 2 bytes to store those types of characters. And that quite often makes up a lot of data that's in databases. So
that's Unicode.
It's Unicode, yeah. That's the terminology that's used. So what we do is we prefix an N to the data type to indicate that it's a wide character, as we call it. It's a Unicode character. Some interesting dates and times, or date and time data types that you can have. There's datetime and datetime2, which have some slight differences. Datetime2 was obviously added later on to a different level of accuracy. And we've got individual date, individual time, all sorts of things there that we can store dates and times with. We can store binary data. You can store straightforward binary from an audio file or something like that. Or there's a data type called image, which is effectively binary. It's for storing image type things. And there's various other more esoteric data types like XML, where you can store an XML document or string. Or geography and geometry, where we can store location-based data and shapes that are defined by points on a plane or on the globe. So all sorts of different data types. The important thing is understanding the compatibility between those types from the point of view of using Transact SQL. And that really takes us on to talk about data type conversion. How do I convert between these 2 different data types? So the obvious one is implicit conversion. And we saw earlier on, I'm able to concatenate 2 strings. One might be a varchar, one might be a char, or one might be a varchar, one might be an nvarchar, but I can still concatenate them because those are compatible. They're both fundamentally strings. And the same with numbers. I could have an integer and a real number that has a decimal place. And if I try and add them together, SQL Server knows that they're numbers. It knows how to add numbers, so it's able to do that. So there's implicit conversion between those very specific subtypes, if you like. But then you've got issues where perhaps you need to convert a number to a string in order to add it together. And at that point, it's not going to work implicitly. So we have to use explicit conversion. And there's a number of ways we can do this. There's a number of functions in SQL Server that you can use to convert data from one type to another, as long as it's, the value that's in there is actually compatible. So there's cast and convert, which, as we'll see when we have a look at the demo, are pretty much the same thing, to be honest. They have the same functionality. They effectively let us change one data type explicitly to another data type. Convert, I tend to favor using convert, especially when I'm working with dates, because it has a number of options for formatting dates that I'm converting between strings. And incidentally, dates is an interesting one. Date, you can have an implicit conversion between a date and a string. Jeff, can you think of any reasons why I might not want to rely on implicit conversion between dates and strings?
Probably the biggest one is the order of dates. So if I put in 05, 2015, actually no, that would be the same way.
Yeah, but same, whichever way you did it, yeah.
If I put in 05, 06, 2015, do I mean the 5th of June or do I mean the 6th of May? And that will depend on where I am in the world.
Yeah.
So and actually it would work because it's going to work in either system, but is it correct?
Yeah, I might store the wrong date. Yeah, so exactly. Date order it varies by locale. There are a number of standards for writing down dates that are used in multinational systems, and we'll talk a little bit about those in a while. But if I just have somebody enter a date as a string and then rely on that implicitly being converted to a date, I might get the month and day order wrong, or there are various other things in there as well that might trip me up, like the time factor might be different as well. So you usually don't rely on implicit conversion of dates. You can do to a certain extent, but you usually don't. You usually use explicit conversion. And the convert function itself has a number of options for saying I want to convert, especially if you're going from date to string, I want to convert this date to a string in this specific format. So perhaps one of the ISO format or the ANSI format for dates. There's also parse, which is used to parse something that you believe to be a number in order to convert it into a number. And there's stir, which is kind of the opposite. It's to take a number and make it into a string, effectively. You'll notice that with cast, convert, and parse, there are try variants of those things. And what we're saying there is, if I try to cast the string O-N-E, the word 1, and try and cast that as a number, of course it's going to fail because written out O-N-E isn't actually a number. And if I just use cast, I'm going to get an error at that point. If I use try cast, it will try to convert it, and if it fails, it will return null. So it doesn't cause the statement to fail, it just doesn't actually convert it, it just returns, I don't know what that is, that's a null.
So all those sizes you had that were 58s, those could be converted over, and even though there's some larges and smalls in there, they'll just...
Yeah, I could try to cast them, it'll convert the ones it can and ignore the ones it can't effectively. Okay, let's look at a demo of working with data types then. So the first thing I'm going to do is I'm going to use that cast function that we talked about, and I'm going to take the product ID, which is a number, and I'm going to change it into a character, into varchar, so a 5-character, maximum 5-character length string, and I'm going to concatenate that using the plus operator to the product name. So if I just select that, and that, again, one of the advantages of using a tool is I can select which statements I want to run, so it's not going to run anything else other than what's selected. Click execute, and sure enough, it comes back, product name, and it's concatenated the product ID. Now, if I tried that without the cast, it would fail because it would be trying to concatenate a number to a string. So the cast is crucial in this case. And the excuse me, the cast syntax is product ID as, and then whatever data type. Convert, it does pretty much the same thing. So in this case, I'm converting the to a character. The syntax is slightly different. Convert to a varchar the product ID. And again, I'm just concatenating it. So we'll run that. And that works in exactly the same way. So I can see how that works. I mentioned earlier on the advantage of convert. It really comes into its own when you work with dates. You've got these options for different date types. So you can see I'm selecting a column called sell start date, which is the date we started selling the product. I'm also then, so I'm selecting it just as it is in the database. I'm then selecting it using convert to a character, so converting it to an envarchar, a Unicode character string, and just calling it converted date. So just accepting the default conversion options. And then I've got another column where I'm selecting again the sell start date, converting it, and I've specified this code here, 126. There are various different codes that reference formats for dates, and these are documented in the documentation. When you're doing the labs, you'll find a link to that documentation for what the different codes are. I happen to know that 126 is the code for the ISO standard for date formats. So format this in a way that is standardized across different systems across the world. And if I run that code, I can see the date, the default formatting for that date is just simply the year, the month, the day, and then the time. When I've just converted it without specifying any sort of format, notice what it's done. It's actually converted it to a string that includes the name of the month, the day, the year, and then whether the time is AM or PM. And the ISO format is the year dash month dash day, T to indicate we're now going to look at the time, and then the time in the kind of standard hours, minutes, and seconds.
And those
format.
second two, they're actually text.
Yes.
So if I'm presenting them to Excel or something, it would see them as text. Whereas the first one it sees as a date.
Yeah. Excel's actually probably not the best example, because Excel's pretty smart about recognizing, hey, that's a date, and it then goes and changes its data type. But yeah, you're right. A client application that didn't know would just see that as a string of characters. It wouldn't identify it as a date. So the other thing I talked about was the business of casting numbers. So if I try to cast size as integer, you might remember earlier on that size had both numbers, but also M, L, L for medium, S for small, L for large. Got that wrong. So if I just go ahead and say, right, I'm assuming everything in that column can be cast as an integer, then it's going to fail, and it tells me why it fails. It failed because I tried to convert M for medium to an integer. Well, there isn't an integer M. So what I might do is say, well, look, try to cast it, and where you can, cast it as an integer. Where you can't, return a null. So if I do that, sure enough, the ones that are numeric come back as numbers. The ones that aren't come back as a null value. So it's kind of useful in that it's got me the numbers. I now need to know how to deal with nulls, and we'll talk about that a little later. But hopefully in this demo you've seen some examples of ways that we can explicitly cast one data type to another, and sometimes that's an important thing that you have to do when you're working with tables and you want to start manipulating the values in there. So we talked about working with data types, and one of the things we mentioned earlier on was nulls. We talked about the idea that a null value means unknown or missing. It doesn't mean an empty string, it doesn't mean nothing or zero, it means we don't know what the value of this thing is. So it represents a missing or an unknown value. The ANSI behavior, the American National Standards Institute, has a behavior, because this is ambiguous. Different systems originally all treated nulls different ways. So there is a standard for database systems that says, look, if a value is null, this is the way you should treat it. The result of any expression that includes that null should result in null, because if you try and add something to something that's unknown, the answer is unknown. Yeah. Now you can actually switch that behavior off in SQL Server. There is an option to specify that you want explicitly nulls to mean zero or empty spaces. Really recommend you don't do that. Keep the standard approach switched on, so that if you try and add numbers to nulls, you get null. If you try and concatenate strings to null, you get null. The same is true if you try and compare values that are null. And if you think about this, this is logical. If I don't know your middle name, and I don't know someone else's middle name, I can't check to see if your name's the same as their middle name. It might be, for all I know, but it might not be. So the answer is unknown. So when you compare null to null, when you check, is that null equal to that null, the answer is null. We don't know. Or the answer actually is false. It isn't equal because we can't determine whether null is null. There is a way of checking for that. That sounds really confusing. How do I check to see if something is null? The answer is you check is it null? Right. So if you have a table that you're trying to query and you want to bring back the rows where the price is null, you don't check for price equals null, you check for price is null, and that will then bring back the rows that have a null value in that column. So nulls can be confusing. It's a potential source of confusion. I'm sure you've come across this.
Well, I often find that there's way too many in a database. So, for example, I have a very short address because I live in a village that doesn't have street names, so I technically don't have a street name as a number and a village, and so there's lots of empty fields in that address. So what you're saying is that you know what they are, they're nothing.
Right.
So the difference between them being empty and them being null.
Right.
And that's where the confusion lies, I think, because I think in a lot of databases have those all in as null because no one typed anything in.
Yeah.
And it's just saying, well, okay, you didn't type anything in, so it's unknown. It's not actually unknown, it's known.
Yeah,
It's known
to
and
be
it's nothing.
Nothing, yes.
So we can actually put in 2 speech marks and enter, even in the text. I mean, obviously you can enter a 0, my bonus this year. Or you could enter 2 speech marks for a text string, and that's saying, I know what it is, it's nothing.
Right.
And that's different to null.
Saying that it's null. Yeah. So it is potentially confusing. And when you're querying a database, it becomes important to be able to handle situations where there's null. And to help us do that, Transit SQL includes a number of functions. Just like there were functions to convert data types, values between different data types, there are functions that help us handle nulls. So there's a function, the first one is null. Now I mentioned the syntax earlier on, again, source of confusion. I mentioned it earlier on, when you're comparing nulls, you check for is space null. You're checking to see, is this thing null? The is null function is not the same thing. There's no space in this, so it's is null. And what I can do is I can say is null, a particular column, and if it is null, then return a particular value. So classically what I might do is check for is null address line 2, and if the address line 2 is null, return an empty string. Or is null discount, return 0, because I'm assuming if there's no discount there, then it has to be 0. So you can specify the value you want to use if the column or the variable happens to be null. And kind of the opposite way around from that, coming at it from the other end, I can check for a specific value, and if I find that value, say, well, yeah, use null instead. So what I might do is check for, hey, if the address is an empty string, return a null. If the value is 0, return a null. More likely, it's going to be things like, if I've got a color field, we'll see this in a little while in the demo, if I've got a color field and it's multi, I want to treat that as null, because that's, for the purposes of what I'm doing, that's confusing. So just return it as null. And then there's this slightly more esoteric case called coalesce. Jeff, do you want to talk us through coalesce?
Well, you're going to sometimes get situations where you've got multiple different columns and some of them will contain nulls, and you've got an order and you say, I'd like to display the first column, but if it is null, then I'll fall back to the second and maybe third, fourth columns. So we had an example where we were talking about email addresses, and you say, okay, I'd like to contact someone by email address. I don't have everyone's email address. Now, that's a classic correct use of null, because almost certainly nowadays everyone does have an email address, so it's
you just
unknown.
don't know what it is, yeah.
It's not that it doesn't exist, like my middle name, you don't know what it is. And I'm not telling you.
I will find out.
So if we don't have their email address, which is null because we don't know it, we would like to display their telephone number. Now, maybe I don't have their home telephone number either, in which case I'd like to display their cell phone number. And you could carry on and on and on and on, but ultimately saying, okay, let's find the best case scenario value and display that. If ultimately they're all null, we'll still display a null.
Still don't know a telephone number, yeah.
Hopefully we have some means of communicating.
So the case might be a classic address book where you've got, I'm sure we've all seen this on your, actually you may not have seen an address book, but on your phone, I'm sure there's an address book there where you have multiple fields for phone numbers.
Did that used to actually be a book?
Yeah, it used to be a paper book, yeah. And you have to score things out and replace them, yeah. But in a cell phone system, you might have multiple telephone number fields for home number, work number, mobile number, emergency number, whatever it might be. And what we might be doing in this case is saying, right, find the first one in this order. If I have a home number, I want that. If I don't, try the cell phone number. If I don't have that, try the work phone number, and bring back whichever value you find first. So coalesce is a function that lets me specify multiple columns and try to find the first null one. And if they're all null, I return null. So let's have a look at some examples of working with null values. And I'm going to stay in my SQL Server Management Studio interface that I have here, but I'm going to open up another script file here. And the first thing I'm going to do is I'm going to say, well, I've got this idea of a size. You might remember earlier on, in fact, we've still got the query, I think, in here, where we cast the size as a number. And actually the results are there. So some of some of the sizes were numeric, so I was able to cast them. But the ones that weren't come back as null, because I obviously don't know what those values are. So what we're going to do in this case is we're going to slightly extend that. We're going to say, well, try and cast the number as an integer. If you can't do that, if the value itself isn't a number, if the size isn't a number, that will return a null. So the try cast will return null. If it does return null, then use 0, is what we're saying here. So we've got a function within a function, and we'll just run that. And this time it brings back the size. Where it is a number, it brings back the size. Where it was either a string or it was null or whatever it might be, it's brought back a 0. So I haven't got any nulls in my results here, because where I had nulls, I've converted them to zeros. And similarly, I could do the same with strings. In this case, I'm checking for color. And I'm using this because I want to concatenate the color and the size together. And in a previous demo, we concatenated color and size, and if either one of them was null, remember that any expression that uses one null value, the result was always null, even although we knew what the size was in some cases, or we knew what the color was. What we're doing here is checking to see if it's null, and if it is, make it an empty string, which can be concatenated. So if we then try that, what we'll find is even in cases where I've got one but not the other, I still get the value. We can worry about the trailing commas a bit later. It's just a detail at the moment.
I wouldn't have picked that up.
Oh, well, there you go.
There you go. There you go with that one.
But it's it's able to check to see if the color is null, then convert it to an empty string. So I've worked with both numbers and with strings using that, and in fact any data type. So the other thing I can do is the other way around. I can use this null-if function, and in this case I've got multicolor sometimes as the color that's specified. If I actually look down, you can see one there, and there's a multicolor product. But perhaps I want to display a color chart. I don't really want to have a square for multicolor, so I'll ignore that and just treat that as null. So I'm saying make it null if the color is multi. And sure enough, it then comes back with null for that value. The other ones, it has the color. If it was multi, it comes back with null.
And you could even then convert those.
Yes. You could do an is null around those and convert them to something else.
Yes.
So the other thing we talked about was this coalesce function, where I can take multiple columns and find the first one that's not null. And there's 3 dates in that product table that I care about. There's potentially a date that the product was discontinued. If it hasn't been discontinued, if it's still an active product, that will be null. But there might well be a date where I stopped selling it. I haven't discontinued it, but I stopped selling it at a particular date. I might restart again, which is why I haven't discontinued it. So I might check for the sell end date. And if that's null, then I'm still selling it, in which case there should be a sell start date, the date that I started selling it. So I can go and check for that and coalesce those values together. And what I get is a date for every column that's in that every row that's in there. I get a date. Now the problem is, of course, I don't have any idea which of these things it is. So I might want to make the function a little more sophisticated and indicate somehow. But you can see how that coalesce function works. Now, one thing we didn't really talk about on the slides, but I do want to show in the demo, the functions that we've used up till now have been functions to work with nulls. We can use another type of expression, another clause in our Transact SQL called the case clause. And case is used to have a column where the value depends on some logic that I want to work out. So what I'm doing here is an example of something called a search case. I'm saying bring back the name, and then for the second column, which we're calling as sales status, we're going to use this case expression to figure out what should go in this column. And what I'm saying is, in cases where the sell end date is null, then put on sale. So we're going to return a string column in this case where we're saying if the sell end date is null, then we haven't stopped selling it, so it's on sale. Otherwise, if the sell end date isn't null, else, then return discontinued. So now I'm getting, rather than that coalesce thing where I could see the dates, but I didn't really know which dates they were, I'm using case to actually make some logical sense of what I'm seeing in those
And you
dates.
could combine the two.
Yeah.
And then actually have a date and you know what that date is rather than it just being a date that could mean anything.
Exactly. So if I run that, we can actually see the results that come back. Some products are on sale because the sell end date was null, whereas other ones, the sell end date wasn't null, and then those ones are discontinued. So we can actually see that logic. Now that searched case, there are two variants of the case statement. You'll notice that the way that works, it's case and then when, and I check in the when clause what it is I want to check for. There is another example of case. There's a simple case that I just want to cover off just for completeness. There's a case statement where I can say case and then a specific column or variable. So in this case, look at the size column, and when it's S, then return small. When it's M, then return medium. When it's L, return large, XL, extra large. Otherwise, return if it's null. If it's not null, return it, but if otherwise, return N8. Right? So I'm going to return, some of my sizes are numbers, I'll return the number. And if I haven't got anything, if it's null, then return not applicable. Size isn't applicable to this particular product. Like a spanner, for example. So, and return all of that as product size. So it's a bit of a more, although it's a simple case expression, there's more options going on in this one because I've added more when clauses. And there's a catch-all else at the bottom. If I run that, in the results, which I'll just bring up so we can see them a bit more clearly, you can see that where it was a number, this was the case else. So it wasn't any of these things, case else. However, it wasn't null, so we return what it actually is. So that's the value that's in the column, 58. This case, it wasn't SML or XL. It must have been null in that case, so we return NA. And in this case, it must have been M, so we return medium. So you can kind of see the logic of how it's worked through that simple case expression. So what we've seen here, it's worth emphasizing the case expression is not explicitly designed just to deal with things that might be null, but it turns out to be very useful when you're checking to see if something's null, to use that case expression to say, well, if it's this, then do something else. If it's that, then do something else. And if it's null, do this. And that's why we've kind of included it at this part of the course.
I think if you're going lots of null conversion, then it might point towards the database design sometimes maybe needing a bit of work that we shouldn't have all these nulls.
Yeah, exactly. If you're a database developer and you're finding these types of queries are common, then yeah, you've probably got too many nulls in the database design. Sometimes, however, you're creating queries to create reports. You have no control over the design of the database, so you just have to deal with it. So that's the end of the first module. We've covered a fair amount of ground. We started off with our basic select statement, having introduced what Transact SQL is and a little bit of the context. We started with our basic select statement. We looked at how to select all of the rows. We looked at selecting specific columns, using aliases to name those columns, using expressions to calculate values that get returned, and then dealing with different data types where I might convert strings to numbers, numbers to strings, dates to strings, that type of thing. And also dealing with values that are null, that are unknown, and how we deal with that. So there's a lot of ground that we've covered. What I would suggest is go and do the lab. And in that lab, you can download the lab instructions. You can set up your database. There's instructions on setting up the database in Azure SQL Database. Use the lab to go and try out some of these things. There's some challenges in there that will make you think. How might you get the results that we're asking you to get? And there are some solution files that you can use to check your answers and compare with what we've produced. So hopefully you'll enjoy doing that. And when you're comfortable with that basic select syntax, you've done the lab and you're happy with that, come back and join us for Module 2, and we'll explore a little bit more about using select in Transact SQL.